Thank you. Hi, everyone. I'm Ayaka Ishii. This is my first time presentation at an international conference. In this talk, I'm going to talk about BubBowl, a display vessel using electrolysis bubbles in drinkable beverages. In this research, we focus on bubbles. Bubbles are everyday material and very familiar and interesting. Thank you so much. For example, we can find bubbles in the water and at the surface of our beverages. There are some researches to present dynamic information using rising bubbles in the water. The information percolator shown in the photo is a display that uses bubbles rising in the water. A lot of transparent tubes are lined up, filled with water, and sending air from the bottom to the tube with an air pump, the display is realized. Also, an electromagnetic bulb is used to control whether or not gas is taken in, and the diffuser is used to improve the display quality by making bubbles appear fine and white. Therefore, these moving parts are required to the number of tubes. As a result, the mechanism becomes large and it is difficult to increase the number of pixels at a low cost. On the other hand, there are several examples of presenting information on the surface of beverages using bubbles. There are examples of printing static information on the surface of beverages. Ripple providing device print static characters and images on the foam surface of beverages, such as coffee, beer, and cocktails, according to a command from a smartphone application. There's also a Shigaraki beer cup that displays a character using bubbles. This is achieved by forming a large surface on the bottom of the cup, according to a pattern of a character. However, these cannot provide dynamic information that changes every moment. This is a table summarizing the issues and features pointed at so far. So, what is a method that does not require moving parts, can present dynamic information, and can use beverages as display media? It's electrolysis. In this research, we propose a liquid surface display using pixels made of bubble clusters generated by electrolysis. We also developed the self-contained peptide device, BubBowl, which generates a dot matrix pattern of 10 by 10 pixels on the surface of the liquid. We use the beverages as an electrolytic solution. BubBowl can realize bubble display using orange juice. The beverages used are edible. This is the example of a bubble display using cafe au lait, and I drank this cafe au lait. Using this feature, a proposed method has the potential to realize an ambient display with bubbles that is familiar to daily life. This is the example of display in a digital clock. In addition, we can print information on the surface of the food, such as a jelly. So why is electrolysis? This table is a comparison of possible methods under the condition of not requiring moving parts and generating pixel dot matrix pattern dynamically and on the surface of the beverages. There are the methods using soda or steam or electrolysis. First of all, the amount of gas obtained from the liquid per 1 kilogram is around 2 liters for soda. But as for the steam and electrolysis, more than 1,000 liters of gas is generated. Therefore, the long-time display can be realized by using steam or electrolysis. As for the possible pixel matrix display methods, in the case of soda, we could realize by pouring the soda into a cup with piezoelectric elements arranged in a matrix on the bottom and controlling the vibration, and steam is generated by heating water with a heater. Electrolysis generates gases from decomposing water by energization. I explain the feature of these methods. Carbon dioxide bubbles in the soda spontaneously emit from areas other than the product of the vibration. Therefore, soda has a low signal-noise ratio. To generate steam, we must boil water and a large amount of energy is required. On the other hand, electrolysis needs just small amount of energy, of around 0.2 milliampere per pixel. So, by using electrolysis, we can realize high quality and low-cost bubble display. I explain a proposed method. In this picture, a dot character A is displayed on the liquid surface in the cup. The liquid in the cup is coffee. A 5 dots that form a dot character is a cluster of the bubbles of hydrogen. We use this cluster as 1 pixel. I will show you how it works. Nothing is displayed at first, but a character A gradually floats on the surface of the coffee. And leave it for a while. Bubble disappear naturally. And this time, character B emerges. The features of the proposed method are smaller, lower cost, lower noise, and lower energy than the conventional bubble displays. This is because our technique requires neither a gas supply from the outside nor moving parts, and we can use circuit implementation technology such as PCB and a higher density of matrix electrodes. Therefore, we think a higher resolution display can easily be realized. In addition, we can render bubble display small enough to be embedded in everyday objects, and it can be utilized in daily life. For example, our system can provide bubble display for the daily information such as weather report and market index on the surface of the coffee. Also, we can implement bubble display as battery operated and standalone. Next, I'd like to talk about our implementation. We installed electrodes in the liquid vessel, controlled energization to the electrode with the matrix circuit, and realized the bubble display by putting in electrolytic solution. So BubBowl needs these elements. We used a plastic cup as the liquid vessel. The electrodes for pixel display are only cathodes and are arranged in a 10 by 10 matrix. And on the other hand, the anode is common, and we place it along the wall inside the vessel. We selected the electrode material that does not elute and deteriorate during the electrolysis. Because the cathode does not elute regardless of the material, we used off-the-shelf pinhead parts that are easy to mount on the circuit board. On the other hand, anode elutes when using other than gold, platinum, and carbon. In addition, when carbon is used, it reacts with generated oxygen and changes to carbon dioxide and deteriorates. Therefore, we used a pure gold foil that does not elute for the anode. In this research, we used the active matrix method for the matrix circuit. So, each pixel has an FET. 100 pixel electrodes are connected to an active matrix circuit, and several arbitrary electrodes are grounded with the controls from Arduino microcontroller board. Since the grounded electrode functions as a cathode, hydrogen is generated from that electrode. The generated hydrogen rises towards the wall surface and forms white fine bubble cluster. In this way, any pattern can be displayed in hydrogen bubbles. We tested various beverages with which a clear display with bubble clusters was obtained. Example of tested beverages are coffee, cafe au lait, and juice. Other beverages are under survey. There are 3 conditions for the electrolytic solution. First, conductivity. This is necessary for electrolysis. Second, the solution should be colored. This picture is an example of using a colorless and transparent solution. Can you find the bubbles coming out? Bubbles came out from these cathodes. In this way, it was difficult to observe bubbles if the solution was colorless and transparent, so we set up a condition that the solution should be colored. Finally, the slight viscosity. In the initial prototype, we occasionally observed that some of the bubble pixels flow to the wall of the vessel from the original position when using a non-viscous solution. This is how bubbles flow. To prevent this, we need to increase the thickness of the solution. I'll explain about the recipe of each solution shown at the beginning. This coffee contains a small amount of sodium bicarbonate and cornstarch. I drank this coffee and felt the taste was almost indistinguishable from that of anti-free coffee. This is the example of bubble display using cafe au lait. we add milk into the previous coffee instead of adding cornstarch. Under this condition, a clear display with bubble clusters was obtained. This is the example of bubble display using juice. The photo is an example of using orange juice. It can be used as a solution without any additives. That's because juice itself is conductive, colored, and slightly viscous. Next, I'd like to quickly talk about technical evaluation. We evaluated the response time of our display. We switched one of the electrodes on and off and measured black to light gray and white to dark gray response times. The black to light gray response time was time lapse between black and 80% of the maximum lightness by generating bubbles, and the white to dark gray was time lapse between white and 40% black by the fading of the bubbles. These response times were measured for a viscous solution and a non-viscous solution, respectively. The viscous solution had the same concentration as the coffee I talked about before, and the non-viscous solution is obtained by removing only cornstarch from this coffee. This is the result as demonstrated by the white to dark gray result. It took a long time before the bubble disappeared spontaneously, especially when the solution was viscous. Using the viscous solution, the bubbles will be stable, but they will take time to disappear spontaneously. Therefore, the response time can be improved by adjusting the viscosity appropriately according to the situation, such as using a high viscosity solution in the case of a system that is greatly affected by the diffusion of bubbles, and otherwise using a low viscosity solution. Also, in this way, a user breathing on the liquid surface could erase bubbles quickly. So it may be possible to improve by such interaction. I'm going to talk about several applications. The proposed system generates bubble pixels on a water surface at low cost, and it is compact and has a silent mechanism. So it can provide display function to decorations that use water in living spaces like this. It shows the time of 12:34 on the water surface in the bowl for Japanese flower arrangement. By incorporating the display function into these things, an ambient display in the living space can be realized at low cost. This is an example of an ambient display by BubBowl. As shown in the video on the left, it is possible to display an ambient digital clock. It is also possible to present any messages up to 4 characters long. The right video shows the BubBowl display that presents the message lab. Next is information beverages. We believe that display media can be edible by using materials that are harmless to the human body. Conditions that are harmless in the electrolysis process are that the electrode does not elute and that no harmless gases are generated. The electrode will not elute when pure gold foil is used for the anode. And as for harmless gases, when halide ions are contained in the solution, the halogen is generated. So it is necessary to use a solution that does not contain halide ions. An example of halide ions is chloride ions. This is contained by salt, so we should avoid using the solution containing salt, such as salty soup. And next is food printing. Until now, bubbles were displayed on the surface of beverages, but this is a technique of printing information on the food with bubbles. And some raw food material is liquid or paste, hence we can electrolyze them and generate bubbles before the food is cooked. Then, cook them and bubbles are fixated at the surface of the food. We made the grape jelly with the message printed using bubbles on the surface. We made it by mixing agar with 100% grape juice and electrolyzing it while it cooled in a refrigerator. Finally, grayscale display. The proposed system can display binary and grayscale images. And we can realize a grayscale display smoothly by controlling pulse width modulation of the grounding time of each cathode. The figure shows bubbles generated from 4 electrodes with different ground contact times. The duty ratios are from the left for 40, 30, 20, and 10%. We plan to display a natural grayscale images by increasing the number of pixels and applying this grayscale method. So, conclusion, and thank you for your attention.
So questions. I know you have questions. I will kick it off, but someone should come up with a good question. So I was curious, you talked about grayscale.
Yes.
Did you think about changing the aperture of the electrolysis to produce other types of shapes? Can you manipulate sort of the point in the liquid? The different shape of the generator, of the bubble generator.
Different shape generator. You mean the display vessel is changeable. We can.
So not like instead of just a circle, can you produce a line or another or other shape?
In the current system, we use the pinhead parts, which is a pillar shape. But we believe the copper pattern, like surface-mounted type copper pattern, circle copper pattern is also possible. And so, as a shape, we will investigate about the other shape. Yeah.
Okay. Have an audience question. Great.
So does the display disappear once you start drinking, or it stays there? Like when you take sips from the liquid?
Sorry, would you say that again, please? Would you say that again, please?
Yeah, does the display disappear when you start drinking, or does it stay?
You mean when I drink the coffee and bubbles? Okay. Yes. When I drink the coffee, bubbles move away from move away, and actually, display is not. I could not see the display clearly, and so we assume that we see the display and drink and set and see. Yeah.
One more question. Yeah, hi. A really fun project.
Thank you so much.
So, in terms of seeing the bubbles in clear liquids, have you considered actually lighting the cup from the side and just like is often done on plastic signs, using the frustrated total internal reflection so that they light up the bubbles?
Yes. Thank you so much. And these bubbles are very white, and light with colored light, and bubbles change colors, and so we'd like to have the light with this system. Yeah, thank you.
Okay, let's thank the speaker.